We're back. We're live. It's Monday. It's 1 o'clock Monday. It's the 1 to 2 block. That means it's the SOEST hour. And SOEST, if you didn't know it by now, is the School of Ocean and Earth Science and Technology at UH Manoa, one of the most important places in the world. You'll see what I mean. Okay, and we have one of the most important people there.
Hardly.
Christina Karamperidou. Did I get that right?
Yeah.
It's a Greek name, and she is a researcher at SOEST in the Atmospheric Science Department, which used to be the Meteorology Department, but too many people thought that meant meteors, and so they changed the atmosphere. I'm only kidding. I don't know why they changed it.
I don't know either, but maybe it's because atmospheric sciences is a little bit more inclusive. I mean, if I say to somebody, I work at the Department of Meteorology, they will be like, oh, you're a meteorologist. And I'm like, not really, I'm a climate scientist. That's a little bit different. I don't really deal with weather. I deal with maybe average weather, which is climate.
Well, if you don't deal with weather, what do you deal with?
Well, okay, as I said, I deal with average weather, and that's
average weather.
Climate.
Okay.
So averaged over seasonal climate or decadal or 30-year means is what we usually refer to as climate.
So,
but I'm mainly here to talk about El Nino.
El Nino.
Yeah.
Yes, we want you to talk about El Nino because we don't understand it and we worry about it also.
We don't understand it either.
Tell us how you got here to this place. I mean, how did you, and I mean this in the sense that I like the high school kids and maybe the college kids out there to know how you did this so that maybe they can think of the same career path.
Right. So I have sort of an unconventional path to El Nino, or maybe not so, but I started as a civil engineer. I started my bachelor's and my master's is in civil engineering, but construction was not very attractive to me, and I was mostly interested in the environmental engineering part of the civil engineering. In most schools, civil and environmental engineering are together as departments. So I was doing a lot of groundwater resources modeling and pollution control, ocean pollution control like plumes, like oil spills and things like that. And also it involved a lot of hydrology. So that moved me towards environmental science. Then I did my, I'm originally from Greece, so I was there. Then I went to Columbia University in New York to do my PhD, and Columbia has the Department of Earth and Environmental Engineering is separate from the civil engineering, and it's closer to the environmental sciences department. So that's how I moved to El Nino research there.
So there was a critical moment where you decided to come to Hawaii with your degree.
Yeah,
Can you talk about that?
Yeah, that was an order actually, or I'm going to explain this. So that the University of Hawaii is a hub for innovation in El Nino research. It has been for many decades. Professors like the late Klaus Wittke or Julian McCreary, Feifei Jean, they have shaped our understanding of El Nino. And then the other center for El Nino research is the Lamont Doherty Earth Observatory of Columbia University in New York. So there you have people like Mark Kane and Steve Zibiak, who have also developed El Nino theory, and also they were the first ones to make a successful El Nino prediction using a dynamical model. So I was there at Columbia doing my PhD, and Mark Kane was one of my advisors. So when I defended my dissertation, and after the committee deliberated, and then they called me in to tell me, oh, congratulations, you got your PhD. And then Mark says, we've discussed and we have decided that you should go to Hawaii and work with Feifei Jean, who's a professor here.
Oh, they just discussed it.
All right,
thank you, gentlemen. That's very nice of you.
it was great because I think these brilliant people figured that the best decision for me as a scientist and as a person is to move to Hawaii and work with Feifei, who is a genius, and I'm very happy that I'm here and I'm working with him.
So what was your dissertation about?
Well, the title of my dissertation is The Interactive Dynamics of Tropical and Extratropical Climate. So part of it was research on El Nino predictability, and then part of it was how El Nino and global warming are affecting mid-latitude circulation dynamics, meaning the jet stream and the storms that we have in outside the tropics. So, and after I came here, I mainly focused on El Nino, since this is the place to study El Nino.
Yeah, sure, right, essentially in the middle of it.
Yeah.
So, but it seems to me, now you can correct me, that the study of El Nino and the study of climate change are inextricably intertwined. And that as we become more sensitive and more curious about climate change, we need to know more about El Nino too. Am I right?
Well,
you can say I'm wrong. It's okay. I'm not a scientist.
I'll speak to that. So El Nino is the dominant pattern of year-to-year climate variability in the tropics, and it has far-reaching impacts everywhere in the world. So it has always been there, as far as we know and as far as we can tell from our paleoclimate data and from current observations and what we know from the models about the future. There's no consensus right now, and there's no strong evidence that climate change is going to affect El Nino towards one direction or the other, being more extreme or less extreme. This is ongoing research, but there's no convincing evidence yet. So what we definitely know is that El Nino will continue to be the dominant pattern of interannual variability, and we care about it because it impacts through its impact on weather and temperature and precipitation every 2 to 7 years that we have one of these events. It affects livelihood, our economy through its impacts on agricultural yield and floods, disaster relief costs, and fisheries and all these things. So we need to understand El Nino regardless of climate change, and we don't yet know exactly how climate change will affect it, if it will.
But from a logical point of view, if we have climate change affecting climate and all these weather processes really everywhere, some places more than others. I read yesterday that the ocean temperature was rising at some astronomical rate off the coast of Maine. It was in the newspaper. So, whoa, who would have thought? Anyway, we have these, all these dramatic things happening in weather, and I guess this leads to the next question: is if that's so, then why wouldn't that affect? Logically, why wouldn't that affect El Nino? El Nino has to be a function of weather, or at least related to weather. Could it be that there's no connection, or is it that we haven't found the connection yet?
El Nino is a complex phenomenon that involves the ocean and the atmosphere. So, it can go one way or the other way very easily, and it's hard to attribute. Every time it happens, it's hard to attribute it to something that is, say, related to climate change. One thing that is very likely, and that was included in the latest report by the Intergovernmental Panel on Climate Change, is that with having more moisture in the atmosphere because of climate change, then it is likely that the impacts of El Nino will be exaggerated because you have more precipitable water, so floods might become more extreme.
That seems logical, but as a scientist, you're not going to make that conclusion until you see evidence of it.
No, I'm going to wait. For now, our models are not agreeing on what will happen to El Nino as a.
Well, why don't we take a moment? We're going to take a break in a little while, but why don't we take a moment and maybe you could help me and the audience by just defining what El Nino is atmospherically.
Yeah.
Okay.
Oh, I should. Okay. So El Nino happens every 2 to 7 years. What's the normal conditions in the tropical Pacific is that you have this so-called warm pool in the West Pacific. You have warm waters, and you have intense precipitation over it in the region of the maritime continent, and you have colder waters in the East Pacific. and off the coast of South America. Now, every 2 to 7 years, the years that you have an El Nino event, the trade winds will slacken, and then you'll have this warm water anomaly in the East Pacific. That means your waters are warmer than usual, and that shifts the region of intense precipitation from the West Pacific over the whirlpool that it normally is towards the center of the Pacific. And that shift of precipitation is what causes all these atmospheric changes in the atmospheric waves, and has all these impacts in temperature and precipitation inside the tropics and outside the tropics. And the kind of the opposite of El Nino is the so-called La Nina phenomenon, and that
what is that? What does El Nino mean in Spanish, and what is La Nina?
El Nino means the child. So as I said, during El Nino years, you have warm waters in the East Pacific. So the Peruvian fishermen, they care a lot about the temperature of the waters there, because when you have these warm waters and off the coast, and you reduce what we call upwelling, so cold, under normal conditions you have cold water coming up, and it brings a lot of nutrients, and the fish like it. There's a lot of food there for them, and the birds like it, and the sea lions like it, because they have also a lot of food. Now, when El Nino happens and the waters are warmer, there's reduced upwelling, so less food for the fish, less fish. So the Peruvian fishermen knew very well about El Nino, and because this phenomenon peaks in December, around Christmas time. El Nino means the child, and it actually refers to the newborn Jesus. So that's why they named that phenomenon, the oceanic part of it, El Nino.
Perfect. So, is just one more question, we'll take a break, and that is, why do I think of Samuel Coleridge and the rhyme of the Ancient Mariner, where he was in irons and there was no wind at all, somehow related to El Nino? Is it true?
Where was it?
It was a long poem.
Mm-hmm.
It was an epical poem. I think he was in the Pacific when this happened, and the Ancient Mariner on his ship talked about being completely in irons, no wind at all for a long time.
Oh,
Is that related to El Nino?
I don't know. What I know as far as the Pacific Ocean goes, and the winds, and how calm the sea is actually the Pacific Ocean was named the Pacific because of the subtropical high pressure systems that are semi-permanent. So that was when Magellan was crossing into the South Pacific, it was November, and November is summer in the southern hemisphere, and that's when the subtropical high system is more intense. That means that it's calm seas, and you have the trade winds that are actually more, as we know, also in our boreal summer in Hawaii. During the summer, we have more steady trade winds, and so easier seas to sail. So then when Magellan crossed into that region in the South Pacific in the austral summertime, he said, "Oh, this is such a peaceful sea, let's name it the Pacific Ocean."
Fair enough. Okay, I'll buy that. But one thing is clear, you would not really have had the same experience had you stayed in Yonkers to study this.
Or in New York.
Columbia.
Yeah, that's for sure. Now I can see El Nino from my backyard. So.
All right. That's Christina Karamperidou. She's a researcher with SOEST in the Atmospheric Science Department. We'll be right back after this short break.
Hi, I'm Donna Blanchard. I'm the host of Center Stage here on the ThinkTech Digital Series. The show is every Wednesday from 2 o'clock to 3 o'clock, and I want you to watch this show because I think that when we talk with artists on the show about what they do, how they do it, and most importantly, why they do it, I believe that it resonates within each of us, and we find something inside of ourselves that brings us closer to all of humanity. That's what arts are there to do, and that's what I'm here to do on this show. That's Center Stage. It's on every Wednesday from 2 to 3 o'clock. I hope to see you there.
Okay, we're back. We're live. We're here with Christina Karamperidou. She's a researcher at SOEST, the School of Ocean, Earth Science, and Technology. And guess what? It's Monday, 1 to 2. This is the SOEST Hour. And so we're learning about atmospheric science and weather conditions in Hawaii. And what I'd like to cover with you now, Christina, is exactly how does this affect, how does the El Nino phenomenon affect us? You know, because I mean, you see it in the newspaper and you hear about it, and maybe you have a show with somebody who knows about El Nino, but mostly it seems like every other year. Why is a year different, and how different is it from my ordinary life on the beach?
Okay. For your ordinary life in Hawaii, when there's an El Nino year, the winters are drier than usual. So you would care about that because you care about water resources on the island. You also care about El Nino in Hawaii because during El Nino years, the East Pacific hurricane season is more intense. So you have warmer waters, you have decreased trade winds, and so you would have more hurricanes forming. Now, of course, it's not the same for everybody. You could be in the Atlantic, and you would really like El Nino for what it does to your hurricane season because it makes it more quiet. So,
I mean, it's worldwide.
It's
El
worldwide.
Nino is worldwide.
El Nino has this worldwide, global impacts all the way from Southeast Africa to to obviously North America and
Asia,
California,
Indian
Asia,
Ocean.
yeah, the Indian Ocean, Australia, of course. You have California has severe floods when there is a big El Nino, and actually there was discussion about that. There's this ongoing drought in California, and then there is still an El Nino watch this year. So the projection from the models is that we will have an El Nino event. Back in the spring, we thought that the El Nino would be a stronger one than it looks like it will be. And there was a lot of discussion also in the media about how that might relieve California a little bit because they would have rains. But also, the biggest El Nino in the so far in instrumental history was the 1997-98
that's not too
El
long
Nino.
ago.
Yeah, it's still, well, we're
It depends on how old you are.
yeah. It was the first El Nino I had heard of. Anyway. But so then California had floods. It was an ice storm, and that claimed some lives. But overall, for the mainland U.S., it was a net economic gain because it was a milder winter for the east and the mid and the middle of the U.S. So less heating costs. So it has positive and negative.
Okay, I want to catch that point though. Not all El Ninos are the same, and there is a noticeable difference between one and the other. I mean, can it be a major difference where one El Nino is like hardly perceptible,
Yep.
and another one is whoa, this is big time? I mean, how wide is the disparity?
Yeah, and that's because we know our weather system is chaotic, right? So you would have, if you see a map of El Nino impacts, that would be sort of a change in the seasonal mean of your weather, but that doesn't necessarily mean that you could not have a storm going all the way to being a huge flood or not. You have there's many steps. Is what we refer to in our scientific jargon as this non-linearity of effects of El Nino.
Non-linearity.
Yes, so it's not as it's this small El Nino, so the impact will be small, or if it's really big, the impact would be really big. You can have a smaller El Nino that would like spin off into something very noticeable in terms of your precipitation or not. So,
And El Ninos have different intensity in different parts of the world. So
Yes,
you could
there-
find, for example, that it would be, I'm just making this up, but you could find, for example, that in the North Pacific would be much more noticeable than in the South in a given year, or in the Pacific would be more noticeable than the Atlantic in a given year.
Yes, that's true, and also it depends what we are, and that's part of my research as well. Lately, there's been a lot of interest in the so-called El Nino flavors or the variations of the El Nino phenomenon. So you have the so-called Eastern Pacific El Nino and the Central Pacific El Nino. So the Eastern Pacific El Nino is when it's like 97, 98, or 1982, 83, where your greatest anomaly in your water temperatures is in the Far East Pacific, and then the Central Pacific El Niños are the ones where your warmer waters are mainly located in the Central Pacific. So these two, so the special pattern of the warm water anomaly during an El Nino, it matters for the impacts. I was last month. We did this research field trip on Christmas Island. It's a little bit south from here, at 2 degrees north of the equator. There in the Central Pacific, the center of El Nino activity. And in 2009 there was an El Nino. A lot of the world outside the tropics didn't really feel it, but then we were there and we were talking to them at school about El Nino. And then the kids sometimes say, "Was 2009 El Nino?" Because they would remember they were like 6th graders. And we were like, "Yes." And they had huge floods. They had to move a whole village because of the floods. They were swimming on the streets, and they had very lively memories of that. And we were like, the rest of a lot of parts in the world that felt the 97, 98 El Nino, they didn't really care about the 2009 El Nino. So.
You also mentioned something that really captivates me because I studied economics back in college, and you said that El Nino had a discernible effect on economies worldwide, I guess.
Yeah.
But economies have a lot of other factors going on. So how do you isolate the effect of an El Nino on an economy when economies are affected by so many other things? Is there a way to do that, which is scientifically, measurable?
Well, it is true. We have to be very, very careful when we attribute conditions to El Nino. You can mainly do that through, you see, in agricultural yield, for example, and that I guess you can translate directly into your GDP or something. You can see how this huge drops in agricultural yield in places like Zimbabwe, for example, in Southeast Africa, they have a drought during El Nino. So
you look at places that are more sensitive to the weather. If you want to find an economy that is sensitive to the weather, that would be a good metric.
Oh, if the economy would be a metric of how severe an El Nino was?
I mean, an industrial nation, say Germany.
Yeah.
It's harder to find it there.
Mm-hmm. Yeah, and that's one point I want to make about El Nino and also about climate change, that we in Europe or North America, and we have more resilient economies to the weather or climate change because we're developed, we have the resources to mitigate and adapt and all these things. But in developing countries or in economies like Christmas Island, or it's you really feel it, and this is sort of the injustice in a sense of climate change or of climate variability, that it is the countries that are in a sense the least responsible for they don't emit that much CO2 because they don't have the living standards that come together with that. They're the ones that are more vulnerable to climate change.
Okay.
And
I want to get to the big question now. A big question. Okay, so you said 2 to 7 years.
Yes.
So as boundaries, and I guess that can mean anywhere in the middle, and maybe once in a while it's less than 2 and more than 7.
Yeah, it's an irregular phenomenon.
It's irregular. And your job, your mission, so to speak, should you decide to accept this mission, is predicting them. How do you do that?
Okay, so
I know this is a hard question. I mean, it's a question that deserves a long answer, but try.
Okay, so I'm personally not involved in El Nino forecasting, the seasonal forecasting, or I don't do that. I'm mainly involved in doing more of basic science on El Nino, so understanding how it works, and that obviously it translates into being able to predict it better. We haven't so we have our climate models, our dynamical models. We have statistical models as well, and we have hybrid models that issue predictions about El Nino based on you have measurements, you have observations, you put them in the model solves the equations, and based on these physical principles, it gives you a prediction about what will happen down the road. And we have a set of models that produces this prediction plume every month or so, and you get an idea about, and that's where these El Nino watches or warnings are based on, the ones that the National Weather Service
So what is
issues.
a warning like? It says, watch out.
Yeah,
El Nino
right now
is
we
coming.
are in El Nino watch. So that was issued in last spring, because most of the models were predicting that we will have an El Nino and potentially a big El Nino. So they issued an El Nino watch so that the governments, the agencies, everybody who is interested, like regional governments or federal governments that are interested in preparing for the impacts, they would know. And back in the spring, the conditions in the atmosphere and the ocean looked very much like the spring of 1997, before that really big El Nino. So that got everybody sort of excited that we'll have a big El Nino. Not because anybody wants to see severe impacts, but scientifically, it's right now we have much better monitoring system and better understanding than we had in '97. So if we would have a big event, it would give us an invaluable source of information for predicting El Nino, and also for understanding its impacts on, say, corals, for example, or marine life. If you're able to measure that live while a big El Nino event is happening, right? Yeah. And that doesn't seem to be the case. It's now the models are showing that the El Nino will likely be a moderate one. But still, these events will keep coming, the big ones and the smaller ones.
I don't have to get out of farming. I don't have to sell all my stock. I don't have to move to another climate. It's okay this time.
Well, yeah, and as I said, El Nino has always been here as far as we know, and will always be here. So societies, they have faced El Nino impacts over and over again. So they may not know the name for it, but they've adapted to it or mitigated it.
But if I'm a farmer, big agriculture is not in Hawaii, but if I'm a farmer in an area which is doing big agriculture, and every tiny degree of change in my outcome, in the crops that I'm able to deliver, the quality of those crops makes a difference, and maybe in big bucks. So to me, the degree of severity of an El Nino means something, and the more you learn about it, the more accurately you can tell me about what's happening, the better off I am, because I can tune my operation so as not to be affected by it.
Yeah, and that's part of why the reinsurance companies are very much interested in climate prediction, and that's another field of work for people that for climate scientists or meteorologists.
So they get hired.
I don't know, because the reinsurance companies will insure insurance companies against these big impacts that end up with big claims. And they will also insure whole governments, like Brazilian government, for their agriculture. So they are employing people to actually make these predictions, so that they figure out, I don't know how exactly, the economic part of it works, but they will figure out the insurance costs and all these based on seasonal predictions of climate.
That's the thing about meteorology, now known as atmospheric science. It's big, it's global. It involves a lot of people, a lot of countries, and the more we learn about it, the more so that is the case.
And
let's take a short break, if you don't mind. That's Christina Karamperidou. She is a SOEST researcher studying and researching in atmospheric science at SOEST, and this is the SOEST Hour. I'm Jay Fidell. We'll be right back after the short break.
Aloha, my name is David Day, and I'm really interested in international business, foreign policy, geopolitics, and national security, and that's why I host ThinkTech Global. I bring in guests from all over the world who know about these various issues in enormous depth and detail. Come learn with me every Thursday afternoon right here at 4 o'clock. I'll see you there.
You spend your day.
My day.
Okay, we're back. We're live. I'm Jay Fidell. This is the SOEST show. We're talking about atmospheric science today. We also refer to that as meteorology with Christina Karamperidou. That's a Greek name. Charming, actually. She's a researcher at SOEST. And I wanted to sort of get a handle, again, for the career planning process, because everybody I interview from SOEST, I want to be that person. I want to be a scientist. I always wanted to be a scientist. I went into the wrong field. Anyway, how do you spend your day?
I work on the computer.
Doing what?
I'm either analyzing data or running models, reading papers, and a big part of what we do is, we come up with ideas. We have to design experiments to test our hypotheses for, El Nino or any other phenomenon that we're.
Give me an example of a hypothesis that you want to test.
For example, what I'm right now involved with, and it's my main project, is El Nino in the mid-Holocene. That's 6,000 years ago, and the interest is how El Nino changed in response to changes in the Earth's orbit. So that would change the seasonal cycle. So in a sense, it's a question about how El Nino interacts with the seasons. So our the way this hypothesis came, I'll tell you about the hypothesis, that we have we have paleoclimate data.
How do we have that?
So we have fossil
Who
corals.
do you call for that?
We call the data people, and sometimes we get to join them, like I did last month, and that was an awesome experience. But so you have lake sediments, ocean sediments. You have fossil corals that give you an idea. They act as proxies for changes in sea surface temperature, salinity, precipitation. So from that, you interpret that and you create a time series of how, say, precipitation varied in parts of the tropics, and subsequently you translate that into El Nino variability changes. So how do you form a hypothesis? I realized at some point that the paleoclimate data from the Eastern Pacific and from the Central Pacific seemed to be a little bit in disagreement about what they were telling us about El Nino in the mid-Holocene. And the data from the Eastern Pacific, they were showing this huge decrease in El Nino events, and then the ones from the Central Pacific not so much. So the hypothesis that we came up with was that, okay, so maybe it was not actually that El Nino was shut down overall or whatever. It was that there was a change in the relative frequency of the El Nino flavors that I was talking about before, the Central Pacific and the Eastern Pacific El Nino. So then that was our hypothesis, that the two El Nino variants responded differently to the changes in the seasons 6,000 years ago. And then we run models to test this, and then if the models agree with what the data are saying, then we're very happy. And
then you write a paper and it goes in the journal of Science or Nature or something.
That's what we are doing now. Yeah.
Have you been published with this kind?
With Nature Science?
Yeah.
Myself, no.
Okay, but it's coming soon.
Hopefully, yeah.
Yeah, okay. So, but why did you choose what is it called,
Paleoclimate.
paleoclimate instead of 1952?
Well, the reason why we look at paleoclimate is because, well, one of the reasons is we would like to validate our models, right? So we don't have data about the future, but we have data about, from the past. So what we do is that if a model is able to simulate accurately the conditions for periods where we have data, then we have that much more.
And it's over a longer period of time.
Yeah, we have, and the other part is, so we believe more in our model if it's able to reproduce what happened in the past. And then as far as, why not just 20th century, why go further back, is because further back we've had these big shocks to the system, right? Changes in the orbit, like big changes in greenhouse gas concentrations in the atmosphere. So you would like to see, if you're getting the physics right, then your model should be able to respond correctly to these big shocks. And because during the 20th century, we more or less had the climate that we know today in terms of, we have increased greenhouse gas emissions, of course, that have led to our increase in global temperatures. But this is not nowhere close to the big shocks that we've had with changes in the orbit.
So it makes it more interesting anyway.
And in a sense, for me personally, I always think that paleoclimate science and planetary science, for example, like what's going on in the atmospheres of other planets, is it forces you to forego your intuition and really realize whether you as a scientist understand the equations and the physics, because part of what we understand about climate and weather actually comes from our intuition. And if you go to another planet, or if you go to thousands of years ago, then you have to just let that aside.
It's an impediment because weather is part of us. In the way the species has evolved.
Yeah.
We're in tune with the weather, with the lunar cycles and solar cycles and all the things that happen. Our whole civilization is built on climate, isn't it?
Yep, exactly. You build your house for climate, right?
So you said before that you had this awesome experience in finding out, getting the data from the
from the paleoclimate.
Paleoclimate. So how did you get the data? Who did you call? Where is that from?
They called me, so that was in.
They never called me. I want to be clear about this.
I was very happy that they did that, because we as climate modelers and dynamicists or whatever, we don't get to do the data collection ourselves, and sometimes we don't give due appreciation to the people that actually do that.
Okay, here's some appreciation to those guys. Thank you very much.
Give them a hug. It's very hard. So Jessica Conroy, she's a professor at the University of Illinois at Urbana-Champaign, and she organized this trip that was funded by the...
That's where David Lasner went to school, by the way.
Oh.
Here's to Urbana-Champaign. Never mind.
So she organized this trip to go, and it was funded by the University of Illinois, to go get these lake sediments from Christmas Island, and they invited me to join them because we hope that these lake sediments will tell us something about El Nino variability, being that Christmas Island is at the center of El Nino variability. So it was a great experience for me. I hope that I would urge all climate scientists that are not involved in data collection to actually try to get involved. And apart from, working these 12-hour days and getting dirty there, trying to get that core, and it requires a lot of muscle to push down that tube and get that. It's a great experience, and it's great to go to these remote places and meet the people that are actually greatly affected by what you're doing. One of the best parts of that trip was the lecture we gave the class in the elementary school, and that was awesome.
Why? What was about it that made it awesome?
It was this. What I mentioned before, when the kids were like, "Oh, 2009 was it an El Nino?" They had never heard about El Nino before. We gave them this El Nino primer, but you could see how their eyes lit up when they realized that they could actually connect it to one of their life experiences, and that was for me. And they were really asking the right questions, and they were brilliant. And it also made me kind of sad how much they don't have that many opportunities for education. Of course,
yeah. Well, if I went to a classroom here in Oahu, or in Maui, or in the Big Island, what would I find? Do you think? Do kids know about atmospheric science? Do they put it together? Do they ask brilliant questions in the same way? I'm wondering.
I haven't been in a classroom here. What I've done is I've judged for the Hawaii State Engineering and Science Fair.
Oh,
and
sure.
also the
Sure, we cover that every
School.
year, every spring.
Yeah, and
I'll see you there. It's in March or April.
Yes, and February is the Independent Schools District that I did also last year. And I was impressed. These projects are amazing, and these students, the way that they conduct themselves and the way they present their research, some of the projects were really graduate level projects. And so I suppose, and from all schools from all over the state, from the Big Island, and I was really impressed. So I hope I get to find myself in a classroom one of these days.
Yeah. Well, as a researcher, you don't necessarily teach.
I'm involved in, I'm a guest instructor in Professor Jean's El Nino class this semester, and I've done teaching assistantships.
Is there more teaching in your future, you think?
I hope so, because I hope to get a professor.
Oh, to be a professor.
Right.
And professors teach regular.
Yeah.
Okay.
I really enjoy teaching, so I hope I get to do that.
Well, so, I just, I want to get the flavor of what the career is like. I mean, if you had a class out there now, and, they asked you, Professor Karamperidou, assuming you're a professor at that point in time, should we consider that going forward? Because we think that, with climate change and other, changes in the earth, it's going to be more and more an important science. Meteorology, atmospheric science. What would you say to them when they ask you whether it's a reasonable choice of career? They're right there. You can talk to them.
Well, I would tell you that climate science is an exciting field of research, and the most important thing about it, as far as I'm concerned, is that it's so interdisciplinary. So you get to do things like I did. You get to go to a remote place and drill a lake, or you get to do more math if you like math more. You get to do development of computer models if that's your calling. There's so many things and so many ways you can contribute to all aspects of climate science that you can find yourself anywhere in there, I think. So.
Thank you, Christina. That's Christina Karamperidou, a researcher at the Atmospheric Sciences Department at SOEST. It's been great to have you on the show and have this discussion. We got to check back at the time of the science fair.
Thank you.
Thanks so much.